Welcome back to another video in the Learning with Bunty Bhaiya series. I'm trying to explain as I learn myself a couple of things about supply chain. And today, again, we'll continue on this similar topics as we left in the last video, which is again some of the supply chain concepts. And today we'll mostly be talking about segmentation, how it leads to distribution, and this secret ABC that I've put here. Now, without wasting too much time, let's start with what does segmentation mean, and also let me change my pen first. So now segmentation, as the word explains, right, it's how do you differentiate between products in supply chain. So we'll take an example. I don't know how to make it very relevant in terms of your daily life, but okay, never mind. We have a cricket ball, the green one, the wiki cricket ball, right? And then we have, let's say, badminton. Or no, not even badminton, but let's say, that hockey, the ice hockey is played with this thing called puck, which is generally black in color and it's very dense, right? So the wiki ball that you have, we know that its demand is very, I would say, season specific, or let's just assume that it's season specific. So the wiki is demanded in summer, or its demand peaks in summer, while the hockey puck is more or less is a winter sport when rivers freeze, when lakes freeze, or you have an indoor ice stadium, right? Now, if you think about it logically, right, I can't be considering these two products or have a similar or have the same supply chain for these two. Let's say there's a DC, which is also called as distribution center, right? And then I have FCs, which is fulfillment center 1, fulfillment center 2, and fulfillment center 3. And then I have customer 1, customer 2, customer 3, customer 4, customer 5, customer 6, and so on until customer, I don't know, n, right? And these are this, whatever it uh, fulfills the demand at the end. And these three are replenished by these. Now, let's say I know that the summer, the coming back, right? The demand of wiki peaks in summer, the demand of plug weeks in winter, but at the same time, I cannot have zero inventory for this in summer or zero inventory of this in winter. So how do I make sure that my supply chain is treating these two products differently? Now, let's say when summer kicks in let's say we're taking the example of Canada. When the summer kicks in Canada, it's generally, I don't know, like late April, early May, let's just assume, and goes on until like August, let's just assume, right? So in that entire summer here, what I'll do is I'll try to make sure that my wiki balls are near in the fulfillment center, closer to the customer, so that the demand is met very quickly, the lead time is very less. But what it does in that case is, and sorry, just one more before we go there, and the plug are kept in DC, because we know that the demand is low, but it's never zero. So in case there's a customer who wants to do an indoor ice hockey thing, they can still get it, they can come here, place the order. The lead time will increase that, but it will be still aligned, it will be more optimized than keeping everything here, right? Yeah, so now coming back to the wiki ball, yes, we will be able to meet the demand very quickly in this case if everything is there. But if you have understood anything from my last push and pull, the inventory at all these fulfillment centers is going to be way too high, right? So yes, there's some pro to it, but there's also some cons to it. And similarly, when the summer goes off and we are in winter, the scenario sort of flips. You have the wiki balls here, and you have the plugs in all of these centers. So what I'm trying to get at is that two products that may look very similar, they are both sports, they are both played with, I don't know, sticks or some sort of bat, will have a different approach, or when will have a different segmentation when it comes to fulfilling, or when it comes to reaching the end consumer, or when it comes to their individual supply chain. So this is what the segmentation means. There are a couple of things, like for example, what kind of segmentation do you do? It's based on value, it's based on volume, it's based on lead time. And similarly, you can also segment customers. For example, high value, high volume customers, based on their lead time. For example, let's say there's a car manufacturer, you are a tire manufacturer, so you get order your demand, or your customer base is generally either OEMs or the tire repair shop. So the lead time for an OEM would be faster compared to a lead time for the repair shop. So your supply chain to catering to both of these demands will be very different. So this is what is generally covered in segmentation. Sorry. Now let's come to distribution. And when I say distribution, I mean distribution of SKUs. Now, if you've heard about the SKU for the very first time, you're supposed to say SKU. When you say it, it's not SKU or anything, it's called SKU, like the word SKU, right? Now, what does it mean? What does it stand for? It stands for stock keeping unit. What does a stock keeping unit means? Anything, for example, a Wikiball is a SKU, a bat is a SKU, a bat which is for kid versus a bat which is for adult. These are two different SKUs. These are not the same SKU. SKU is anything that, even if it differentiates in terms of color, size, even if it's by a lighter shade, or like a shade which is like one point different in the RGB scale, it's still considered as a different SKU. So SKU is an individual differentiated product. So this is, sorry, we're going a little off topic, but this is basically a SKU. Now I want to explain the distribution part with an example. Let's say like there's a grocery store, right? It has, I don't know, let's say 10 SKUs. Or let's say it has, just to get a good number, it has 100 SKUs. Now, if I were to make a graph right here, which is percentage of products and percentage of revenue, there are three kinds of actually four, but we generally deal with three kinds of distribution. The first kind of distribution is uniform. So what uniform distribution means is, if I were to plot it here, this would show the uniform distribution. Sorry, this line's not very straight, but it's supposed to go in a way. Let's say this is 50% and this is 50%. So this should meet, which means that 50% of the product bring in 50% of the revenue. The another thing that you do is normal, right? You assume that some of the products sell a little more, some of the products sell a little less. But if I were to plot a graph, it would something be like this, which means, let's say 50% of revenue was brought by only 35% of the products. This is called normal distribution, and you must have heard it very often. The third thing is called power law, which says that most of the revenue is brought in by a very low number of products, which means that there are some products which are not sold very often and which are basically a long tail if you were to look at the revenue. If I were to plot this, it would be something like this, which means that, let's say 50% of your total revenue was brought in by only 10% of your products, and let's say this is 100%. Okay, not 100, maybe let's say 80%, and 80% of your revenue was brought in by 35%. I mean, it's not supposed to say that, but it's what I'm trying to tell you is between the 100% of the revenue, share of revenue, and 80%, the 20% that we have will be contributed by 65% of the product, which means there's a very long tail which is bringing in a very less sort of revenue. Now you must have, in some way or other, have realized this power law is used in daily life. And in consulting, there's a principle called Pareto principle, and I think it's a general thing as well, which means 80% of the problems, that if I'm talking about the problems, lies is sorry caused by 20% of activities, or basically the 80-20 principle that we talk about. So this is, the power law is a universal law. It's applicable, I think, almost everywhere. For example, let's say I'm doing a class, I'm giving a lecture somewhere. I'm 100% sure that only 20% of the students are going to ask 90% of 80% of the questions. The rest, most of the class is going to be silent. So this is how we treat, or how we look at, the distribution of skews. Now, what it should, like, the next logical question that you should have after having a look at this graph is, then Digvijay or Bunty Bhaiya, how do we deal with different products? For example, how do we deal with these 10% of the products? Then how do we deal between these 25% of the products? And then how do we deal with the remaining 65% products? And this is where I introduce to you the ABC analysis. ABC, these are the three classes that retailers or anyone on this planet generally uses to classify. A is generally the fast moving, high revenue products. B is moderate moving, okay revenue, if I were to, and C is the long tail. Right? This is what is ABC analysis. Now, the way to deal with the A class of products will be very different from the B, and will be very different from the C. But again, you cannot, the strategy that's, or the logic behind is, it we need to understand that A, since it brings in most of the revenue, this needs to be closer, more available, and should have a faster or much optimized way of selling compared to B, and then compared to C, which is a very long tail. But yeah, this video, I think it's enough for today. ABC analysis, in the next video, what I can do is I can try to solve it mathematically for you on this makeshift whiteboard. But for today, I think it was, I hope it was helpful for you to understand the concept of segmentation, the distribution of skews, these different kinds of distribution, uniform, normal, and the power law, and then a basic introduction of what is an ABC analysis and why is it relevant. So again, like, the same message that I have always for you at the end, in case there's anything that you want me to cover, in case you are facing any problem or you have some confusion about your corporate journey, feel free to reach out to me. Until the next time we meet, stay happy, stay healthy.